Welcome back. In this video, I will show you how to set up Lab 1 starter code using NetBeans. Then I will explain to you the role of each files that are included in Lab 1. To get started, let's create one folder in the desktop and we'll call this folder ITSE4102. The next thing we want to do, let's go to e-learning and choose Lab 1. And in Lab 1, you will find two files, one called lab1.pdf. Here you will find all the activities that are needed or that you should do as part of lab number 1. And the second file is basically your startup code for this lab. So click on this one to download it and then save it to the folder that we have just created. So go to desktop and then ITSE4102 and then click save. Next, go to ITSE4102 folder and you'll find one file. This is basically a compressed zip file. So right click, choose 7-zip and then extract here. This will create a new folder called scanner. Just double click here and you will see this folder structure under scanner. So this is basically a NetBeans project, okay, which means we can open it using NetBeans. So go to the search button in Windows and type NetBeans and click on the NetBeans desktop app icon. And then to open our project, go to File and then Open Project. And then from ITSE4102, choose Scanner and click Open Project. So this is going to open the NetBeans project for you. Let's just take a very quick look at the files that we have under this project. So you'll have two tabs, the project tabs and the file tab. So select the projects tab, which is selected by default, and then under source packages, select scanner and then expand scanner, expand the scanner package basically. You will find four files in here. We're going to take a look first at lex.l. Okay, double click here and this will open the lex.l file. This is the lexical specification file that we have explained in the last lecture. Now the lexical specification file consists of three parts. The first part is called user code. So this part is basically copied as it is in some generated Lexer class. The second part has three sections basically. The first section is what we call the options section. This is basically allows us to modify or choose the generated output, so make some changes to the generated class. So for example, I want my generated class to be named Lexer, and inside that Lexer class I want one method or one function to be created, and that function would be called next token, and this next token will return type token. The second section of part 2 is basically user generated code. So this is basically a definition of two methods. Both of these methods will be created inside the Lexer class. And the last part of the second section is basically the regular definitions part. Now I have two sets of regular definitions. This is the regular definitions that I'll be using frequently in my lexical rules. So here is a regular definition for a line terminator. This basically says a line terminator is basically a carriage return or an end of line or a combination of both carriage return and an end of line. This regular definition here says that a digit is basically any number between 0 and 9, and a number is basically a digit which is repeated one or more times. Okay. The last section or the last part of my lexical analyzer specification is the lexical rules. And as we have seen that we can have lexical rules that are defined within within states. The default states is YY initial, and we have these definitions of lexical rules. So we have lexical rules for keywords. Okay, so you just put the keyword between double quotation, and each lexical rule has two parts, some regular expression and some action code. This is Java code. Okay, and for time being, this Java code would basically return some token, and that token takes as an ID, or basically returns an ID of some token, and it encapsulates whatever ID within this function call. And we have also a token class for identifiers. Now for an identifier, I'm actually returning two pieces of information, an ID as well as the text of that ID. Now the text of the ID is nothing but the name of the ID, and we will see the output and how this thing actually looks like. We have also definitions for operators, and you can just read these and you'll understand what they are doing. And then the last two lexical rules for handling comments and for handling white space. And in this case, our action code basically contains a single comment, so there is no code that actually runs when we are matching comments. So we are basically throwing comments away. The same thing we are doing with white space. So this is our lexical analyzer, or this is our lexical specification file. The second file that you need to take a look at is token.java. This is basically a class which I'm using to manage the information about my tokens. Now each token consists of two pieces of information, an ID and an optional value. This class is basically an extension of another class, so it basically inherits from a simple class, and in a simple class, this simple class is coming from the Java Cub runtime. We'll cover Java Cub later on once we start talking about parsing, so you don't need to worry about the details of this simple class. So I'm just reusing some existing code. That's all what I'm doing in here. Now in the token class there are two constructors. The first constructor takes basically just the ID. So this is for tokens such as the equal, not equal, or keywords. Okay, so this is what I'm using if I'm handling tokens without any attribute values. If I have a token with an attribute value, for example numbers and numbers and IDs, then I'll have two things, some value or some token class identifier, and some value for that token class. And then the last method that I have in my token class is basically toString method, which is going to give me the string representation of my token objects. I also have one file called sim.java. Now this is an interface. An interface is nothing but a class which cannot be instantiated, so you cannot create instances out of this class. That's why all of the fields are basically defined as static fields, and they are basically static final fields. So these are constants. You cannot change the values of these constants. For each kind of token, I'm creating one field and I'm giving them some IDs. So for example, the if token has a value 2, else token has a value 3, the equal token has a value 11. So this is the first set of fields that I'm having. Then I'm also having an array of strings. Now this array of strings allow me to display the names of the tokens, or the names of the token classes. Now you need to make sure that the position of these names in the array matches the value that you give them. Otherwise, the output will not be correct. The last class is listTokens.java. Now listTokens This is basically my driver class. This is the one that contains the main method. This is the one that I will be running if I want to see some output. This class or this main method does two things. First, it asks the user to input the name of a file, and once it reads the name of the file, it creates a new Lexer object, and this Lexer object will contain one method called nextToken. So it will repeatedly call nextToken, which that's why it is placed in a while loop, and for each token that is returned by nextToken is going to go and just print it to the output stream. Now, as you can see, I have a small red line under Lexer class, and the reason I'm having this red line is because I don't have yet a class called Lexer. Okay, I have a lexical specification file, but I have not generated this Lexer class. Now, in order to generate this Lexer class, I need to compile lex.l using JFlex. Now, to do so, let's go back to our folder that we have created. Click in source, scanner, and then copy this path here. Go to the start or to the search button and type cmd. Make sure that you are in the same drive as the folder that you have placed in here. So I'm in the C drive. So what I need to do, I need to just cd and then paste this path here. Just let me check that I'm actually in the right place. So yes, I have lex.l here. So I am in the right place. So the next thing I want to do, I need to compile lex.l. To compile lex.l, I just type JFlex and then lex.l and then hit enter. And this will create for me lexer.java. Now, if you come back to NetBeans, you will find that there has been one new file that has been generated for you, and this is called lexer.java. Now, if you click in lexer.java and you come to the navigator part, you will see the details of all the different methods that has been generated under lexer.java. So you have, for example, one method called nextToken. This is the method that we have specified, or the name of this method has been specified inside lex.l. So this is where we have specified the name of this function. The next thing that we have is token. So two versions of the method token. Okay, this code has been copied directly from lex.l. Okay, now you need to remember one thing about lex.l. Every time you make a change here, make sure that you recompile it using JFlex. So for example, let me just add a new dummy method here. So I'll call it, so let me create a method. I'll call it test, and it returns a string. And this is basically returns some dummy string. Okay, now you type this, or this method now, it's still inside lex.l, but it's not in Lexer. Okay, how do I get it to Lexer? I need to go back and compile lex.l using JFlex. So when I compile it again, now as you can see, lexer.l has changed, and now this method has been added to my lexer.l. Now, so remember that every time you make a change to lex.l, you need to recompile it. Otherwise, lexer.java will not be matching lex.l. You need to remember that in the assignment or in the lab, you need to submit lex.l and not lexer.java. So make sure that you are submitting the correct file. So every time you make a change here, just to recompile it using JFlex. So the last thing we want to do is we want to actually run the lextokens.java. So before running it, let's go to the Files tab, and in the Files tab, expand Scanner, and then expand Data. You'll find two input files here, one called in1.txt and the other one is in2.txt. This is basically some dummy input just to see what kind of output generated by our lexical analyzer. This is basically a file that contains three things: a comment, some dummy statement, and another multi-line comment. As you will see in the output, these comments will be thrown away. So the comments will not be shown in the output, and the reason is because we don't have any action code associated with the lexical rule of a comment. So let's go to list tokens, and to run it, right click and click run file. Now the file is placed under the data folder, and we type in 1.txt, and this is what the output that's going to show us. Okay, so as you can see, I have one token in my file called if, and so it prints the token. So each output line is basically showing you the content of a token. It's showing both the type, and if there is a value, it shows also the value. So I have one token called if, and and another token called a, or it's type ID and has value a, and so on. Okay, now I encourage you to create your own input files to test this list tokens class with your input file. So for example, you can create one file and call it test.txt, and you can type something like if c is equal to 10, then print x, else print y. Again, this code will not make any sense right now because we don't have a parser and we don't have a semantic analyzer as well. Now if I run the file again with the new data file, so data/test.txt, it's going to give me this kind of output. Okay, so this is the code that you have. This is the starter code that you have for this class. Just make sure that you read the slides in the lecture, and make sure that you read the references, and good luck with your lab activity. Thank you very much.